Okay, last time we finished the topic of spot speed studies, and the next one is in the same slides as well, which is about travel time studies. The last thing which we did for spot speed was performing the chi-square test, which tells you if the frequency distribution of the speed data follows normal distribution norm. Okay. Then we moved on to travel time studies. Another name for travel time studies is journey time service. These are some of the applications or reasons of doing the travel time studies: finding out level of service, traffic assignment, economic evaluation, problem locations, and contour maps. Then we were discussing the different techniques for doing the travel time studies. We just discussed the first one of them, which is the test car method, okay, in which you hire a car and there's a driver and there's an observer inside the car, and they are noting down travel time as well as delay. Okay, and this technique can be applied with three variations. It's the same technique, but there are three different variations depending upon where you are doing it: 2-lane highways or multi-lane highways, and for what purpose you are doing it. Finding out the 85th percentile speed or the average speed. Okay. We'll continue with that. Next one is finding out the other techniques which are used for travel time studies. The next one is a license plate method, okay, in which you have observers at the start and end point of your journey, okay, and these observers are noting down the license plate number, okay, and they also note down the time when that license plate number car crossed them, okay, so they know which car and they know what time, okay. So there is one at the start point, one at the end point. Okay. When the survey is finished, they get together, match their license plate numbers. Okay. And wherever the license plate number is matching, they can get the time. Okay. So the same car went to the first point or went from the first point at 9 and reached the last point at 9:30. So you know the travel time. Okay. The only problem with this method is this thing with matching. Okay, so if one observer misses the car, then he cannot have travel time, right? Okay, and this is very common because you will be writing down the whole license plate number, the registration plate number, okay, which can take you 2 to 3 seconds, and that time the other cars will be passing. Okay, so there is no way you can record the license plate numbers of all the cars. Okay. And then there is a problem that maybe you missed some cars which the other person recorded, and vice versa. Okay, so you may have 1,000 values with you. Each observer may have 1,000 values, but the matching values out of them could be only 100. Okay, so this is the problem with this method. Other methods are similar to the first two. Okay, the other methods are similar to the first two. Okay, going back to the license plate method, the advantage of the license plate number is very easy. It does not require any car or something. Okay, just the paper and pen and 2 observers. That's it. Okay, the disadvantages I already told you. The first one, which is the problem with the matching. Okay, you may not have all the values which you have recorded. Okay. The second problem is you know the start time, you know the end time, but what happens between them you don't know. Okay. So maybe the car took half an hour, but for 10 minutes it was stopped somewhere. In the license plate number method, you don't know these things. Clear? In the first method you know everything because the observer is inside the car. Okay. Now these techniques which you see here, they are different variations of the first two methods. Okay. So for example, you can do the observation from a vintage point. Okay. Vintage point is a point from where you can see the entire segment. Okay. A point of good visibility. Vintage means a point of good visibility. Okay. So you are looking at the entire segment, and you see the car going from one point to the other point. see the entire journey of the car. Okay, but again, then you have to find this point. It may not be available. All routes do not have a vantage point. Okay, you need a bridge or a very tall tower or something. Okay. Another variation is we discussed the test car method. So instead of having an observer inside the car, you put some sensors inside the car which will record the time and speed and distance and everything. The car already has it, okay, but they need to be recorded, right? The car already has the speedometer and the odometer and everything, okay, but they need to be recorded. Okay, you can put some sensors which can record these things. Okay, and the last one is instead of manually observing and recording, you can take a video of the segment or the video of the start point and the end point, and later on from the video you record everything. Clear? Okay, so these are different variations of the methods we have discussed. This is our travel time study table. So you see some basic information on the top. Okay, and then we have the points from the start point, okay, and their data. Okay, so these are different points in the journey, and this is the end point of the journey. Okay, the start point is here. Okay, now what are they giving us? The distance, cumulative distance, cumulative travel time, how much delay because of stopping, how many times the car stopped, travel time for each section. So this is cumulative and this is for each section. Okay, and any special notes which you want to mention with your observation. Okay, now if you look at this table, we have mainly discussed two methods, test car and license plate, right? The others are variations of that. Which method is this? Test car or the license plate? Test car. Okay, why not the license plate? There is a delay as well, and then you can see intermediate points, right? Okay, the license plate number don't have this. Okay, so when we say cumulative, so these two columns are cumulative, that means that they are from the first one. So all these numbers are from here. Okay, then we have these numbers or these four columns are for each section. Okay, so each number is from the previous point. Okay, each number is from the previous point. So which point is before this? This one, right? So these numbers are from here to here. Okay, then for these numbers, it's between this and this. Clear? Okay. Okay, and so on and so forth. So if you match, for example, the travel time of each section, you add them together, you should get the same number as you have the cumulative, right? Cumulative and the total should match, right? Okay. So this is a check which we can do, and then here you see why the car was stopped. Okay, these notes are basically for why the car was stopped. Okay, so if there are stops, it's mentioned. If there are no stops, it's not mentioned. Okay, this is a sheet I got, a sample I got from somewhere else. Okay, but it's local. It's on a Bahraini highway. Okay, done by a consultant, and you can see the name of the highway and the time and the date and everything. Okay, and they have mentioned again. So these are basically crossing points. It's a highway. The main highway is which one? This is the main highway. Okay, and the intermediate points are the crossing points where it's crossing. Okay, they noted the distance, the time. Okay, now they are noting the time as per the clock. Okay, so it doesn't start from 0, it starts from 2 p.m. So they start it as 2 p.m. Okay, the reasons are mentioned, not so clear, but they are mentioned. Okay. Now keep one thing in mind, for travel time studies we don't have any new equations. Okay, there are no new equations for applying to travel time data. Okay, everything which we have learned, which we have seen for spot speed will be applied to travel time studies as well. Clear? Okay, so let us look at the first question. We have a hypothetical RT here. So hypothetical means it's imaginary. Is what you go through when you study too much traffic. And imagine highways as well. There will be a highway here. Let me go and drive on it. And you kill yourself. Okay. So that particular highway has a running time of 196 seconds. Okay. Mean running time of 196 seconds. The standard deviation of this data is 15 seconds. Okay. Now, running time is a part of travel time which is without delay. Running time is a part of travel time which is without delay. Okay. So now they are saying, let's assume that this running time also has normal distribution. Okay, which is not a bad assumption because we said earlier any real world data with enough samples should follow normal distribution. Okay. So with this assumption, they are asking us to calculate the average and 95 percentile of speed. Okay, asking us to calculate average and 95 percentile of speed. But they gave us time, right? The data which I have is what? Time. So why are they asking for speed? And how do I calculate the speed then? Yes. Yes. So how much is the distance? Three miles. 3 miles. Yeah. Okay. So distance is given. This is how they can or we can expect to get the speed from travel time data. Okay. So the distance is 3 miles. The mean running time is given. So I can calculate the average speed without any problem. Distance is there, time is there. So the average speed will be its distance upon time. Distance 3. Now time is 196 seconds. Okay, if I keep it in seconds, I will get a very weird number. Okay, I have to convert it to hours. So 55 point anything. Okay, for 95% confidence interval of speed. So for average speed, I use average time, right? For 95% confidence interval of speed, I will use 95% interval of time. So first of all, I have to calculate the 95% interval of time. Okay. 95% confidence interval for a normal distribution, you have already studied the central limit theorem, comes from mean (1.96) E, where E is S upon okay, where S is what? Standard deviation. Do we have it? Okay. And N was what? Which number? Everything is a number. Number of cars, right? Do we know it? No. Okay. Now comes that this is E is a error of a sample. N is number of cars in your sample. Okay. In this study, there is no sample. There is no sample. Okay. How do I know that? Because of two reasons. The first reason is it is hypothetical means what? Imaginary. Okay. There are no samples. Okay. Maybe they simulated. they run the simulation, they design a new highway for future, they run the simulation, this is what they got. Okay, so this could happen. And the second reason is they are saying this mean is true. Okay, so these two things indicate that there is no sample. Okay, otherwise if there is a sample, then the mean will be for the sample, it will not be a true mean. Okay, there's a difference between true and there's a difference between for the sample. Okay, true is without the sample, it's the final value, that's it. It's not for a sample, it will never change. Okay, truth does not change. Agreed? Okay, truth does not change. Okay, so if it had been for a sample, then they would say, okay, this is for the sample, and then somebody can get a new sample, a new value. But this is true, so there is no sample, the value applies to everybody. Clear? Okay, so there is no sample. So what should I do with the E then? In the case when there is no sample, okay, then E can be taken as S directly. Okay, when there is no sample, then E can be taken as S directly. Okay, so instead of doing this 1.96 E, I will do 1.96 S. Clear? Okay, how much is the confidence interval of time here then? You know the mean, you know the standard deviation. Sorry.
29.4.
Huh?
29.4. No,
Me 196.
Huh?
196 mean. 225.4 and with minus okay, so now using these values I can calculate the 95% confidence interval of speed. Okay, again distance upon time, distance remains same, time, these two values, how much? Just like you calculated the mean, only you will change the time. Right? 64.9. Okay, any problem? There? Okay, any questions, any problems? Clear? No? Whatever. Now you have, when you wanted average speed, you did average time upon distance, right? Sorry, distance upon average time, right?
Yes.
Now I need 95% confidence level of speed. So I will do distance upon confidence level of time. Okay? Okay, everybody? Clear? Okay. Another question. Now in this this question, the values are not given. They gave us the frequency distribution. But for speed data, we use the frequency distribution in the form of a table. There was a table. Okay. Here the frequency distribution is given as a bar diagram, or they call it a histogram. Okay, bar diagram or a histogram. So you see the value at the x-axis, and you see the frequency on the y-axis. Okay, you need the value and the frequency, right? So it's given in the form of this bar diagram. And again, the process is the same. We have to find out the average speed and 95% confidence interval of speed. In the previous case, there was no data, mean and standard deviation was given direct. Here we have to calculate the mean and standard deviation. Okay, clear? You can see the equations for mean and standard deviation here. The same which we have used for the spot speed data. Okay, we have to calculate the mean and standard deviation first now. Okay, so I have two values here, right? Values on the x-axis, values on the y-axis. Okay, and I need two things here, n and s. Okay, n was the number of cars and s was, in that case, the middle speed, the value. So this was the number and this was the value. Okay, so which of them will become n? Y-axis, the number, right? Okay, and this will become the s, the value. Okay, first of all, give me the, we need to find out the total. Capital N was the total, right? Okay, so you have the values for each bar. You will add them together, you will get total. Okay, for our convenience, it's given 20. But this is how it is coming. This 20 is the total of the number of each bar. So 1 plus 1 plus 1 plus 2 and so on. Clear? Okay. So total n is 20. Okay, and for each bar I know the n and the value. Okay, give me the mean first. Problem in the small classroom. Okay. Now we need to find out the standard deviation. Okay. Standard deviation, this is the equation. We already know n and s. We already know capital N. Okay. And x bar is 218.5. Okay. So how much is the standard deviation? 249. What is it? 49.4. Okay, pay attention now. I told you a rule about mean and standard deviation. Anybody remembers? There's a rule. I can have an idea if this value is correct or not. There's a check. And what is that check? Should be less than the mean. Okay, so this could be a standard deviation. Okay, now you are back to the situation which we had in the previous example. Okay, the mean is given, the standard deviation is given, and they are asking for the mean speed and the 95% interval of speed. Okay, the only thing which is different here is what?
Time. There is one time.
There is one time.
Yeah, yes.
No, you will, like you did in the previous example, you will calculate the confidence interval of time as well. Okay, but when you are calculating the confidence interval of time, okay, you did it in the last example. This is how we did it, right? Okay, now you look at the bottom. This is the confidence interval of time. What will change in the question we have from this one? What is different?
There is number of the curve.
There is a number. Okay, so I can calculate E as well. Okay, I can calculate E as well. I don't have to suppose E is equal to standard deviation because it's for a sample now. I know there is a sample. Okay. Okay, what is my E value? How much is this?
Square root لما تشوف
11 point. Okay, the rest is the same now. You calculate the confidence interval. Then for average speed, you will use the average time. And for 95% confidence interval of speed, you will use 95% confidence interval of time. Okay, so you have to calculate the average. You can do it directly. You know the mean time and the distance is given with the chart. Okay, for 95% confidence interval, first of all, you have to calculate the 95% confidence interval of time. Okay, and then from there you will calculate the speed. Clear? Okay. 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 This is travel time. Last example, running time. What do I say the difference between them is?
There's no delay over there.
Delay. Okay. The difference between them is delay. So if I take the difference of mean running time and mean travel time, I will get mean delay. Okay. So from these values, I can calculate the delay. Okay, the mean running time was given in the previous question. The mean travel time we calculated in this question. Okay, so you take the difference, the delay is 22.5 minutes. Okay, clear? Now we cannot do it for any two highways. It has to be the same. It has to be the same. Okay, so the assumption behind this is the same highway. Clear? Okay, now this is calculating delay using the travel time data. Calculating delay using the travel time data. We can also calculate delay using the chance, okay, what they call as the probability of occurrence. Okay, what is the chance that this can happen? And the value of the delay itself. Okay, so one method of calculating the delay is half travel time, half running time, the difference between them is delay. Okay, the other method is you find out what is the chance of having the delay, what they call as probability of occurrence. Okay, and the value of the delay itself. Okay, so the example is given. We have a highway with two intersections. A highway with two intersections. At any one intersection, the average delay is 40 seconds, which you can see in the last column. At any one intersection, the average delay is 40 seconds. So I know the value of the delay itself. Okay, but will this happen to everybody? No, because everybody doesn't have to stop at the intersection. Okay, so there are people who go with 0 stops. Okay, there are people who stop at 1. There are people who stop at both of them. Okay, so if somebody stops at 1 or somebody doesn't stop, his delay is 0. If he stops at 1, his delay is 40 because 1 is 40. If he stops at both of them, then his delay is 80. Okay, now how will I calculate the average delay of the whole highway? Okay, of the full highway. Okay, because this is for each intersection now. Okay, so I will use the delay and its chance. Okay, so that mean delay in this case will be the product of the value of delay and its chance. Okay, so the value of delay, first one is 0, right? What is chance? 0.569, meaning 56.9%. Okay, 56.9%. What is the next value of delay? 40. What is the chance? 0.3. Next value of delay? 80. What is the chance? 0.131. Okay, so this will give you the total of the entire highway. And how much is that? Take this calculator, please. Somebody.
This is
No, no, I should calculate.
22.5.
22.5.
أنا تقريبا 22.5.
Yeah.
ده قاعد أنا أنا ضايق على الموضوع.
I was looking at the clock. 1:50 now. I can give the calculator. I'm getting the rate now. Clear? Okay. Okay. We'll do it next. Okay. Any questions?